Good afternoon. Welcome to Basic Electrical Engineering Unit 1, Lecture 4. Today we shall discuss source transformation technique, KVL and KCL, Kirchhoff's voltage law and Kirchhoff's current law. Source transformation. A source transformation is a network reduction technique wherein one form of source can be interchanged with its another equivalent form. Using this technique, a complicated network can be converted into a simple form and hence calculation can be made easier. Basically, there are two types of sources, that is voltage source and current source. Converting a voltage source to a current source. It is a process of replacing a voltage source in series with a resistance by a current source in parallel with a resistance. As you can see, there is a voltage source Vs in series with resistance. The terminals have open circuit voltage of Vs. This can be converted to a current source in parallel with the resistance Is, and resistance is R. The value of Is will be Vs by R. From Ohm's law, V is equal to I into R. Therefore, I is equal to V by R. So Is value will be Vs by R, and the resistance value does not change, it remains same. Converting a current source to a voltage source. As you know, the current source will be having a resistance in parallel. This must be converted to a voltage source in series with a resistance. Let's suppose there is a current source Is in parallel with a resistance R. This can be converted to a voltage source in series with a resistance R, where the value of this voltage source will be Is into R. By Ohm's law, V is equal to I into R, right? So Vs is equal to Is into R. Now taking an example, let's take there is a current source in parallel with the resistance. The current source value is 5 amperes and the resistance value is 5 ohms. So the question is, determine the equivalent voltage source for the current source shown in the figure. So there is a current source in parallel with resistance. This has to be converted to a voltage source in series with a resistance. The voltage is 20. The voltage across the terminals AB is equal to V is equal to I into R. So 5 into 5 will be 25 volts, and the resistance value does not change. So the equivalent will be a voltage source of value 25, that is I into R 5 into 5, and resistance value is 5 ohms. Now let's take another example, a voltage source in series with a resistance, and the value of voltage source is 50 volts and the resistance value is 30 ohms. The question is, determine the equivalent current source for the voltage source shown in the figure. So I is equal to V by R by Ohm's law. So 50 by 30 will give you 1.66 amperes. That is the value of the current source, and the resistance value does not change, it is 30 ohms. So the equivalent will be a current source of 1.66 amperes in parallel with the resistance. Now let's take another example. Example 3. Find the voltage V0 in the circuit shown below using source transformation. There are two sources, one is the voltage source and the current source. A resistor is connected in parallel to the current source, and a resistor is connected to the voltage source in series, and we are asked to find voltage across 8 ohm resistor. You can also solve this by using other laws like Kirchhoff's current law or voltage law, or some other methods, but here we are asked to find using source transformation technique. So first we'll try to convert this current source into current source of 3 amperes in parallel with resistance 4. That will give you 4 into 3, 12 volts in series with 4 ohms. And now 4 ohms and 2 ohms will be in series, and we'll also convert this 12 volts in series with the resistance 3 ohms to a current source. So I value will be V by R. 12 by 3 is 4 amperes. This is how the circuit will be. 12 volts in series with 4, and 4 plus 2 is 6, and here the to the right the voltage source is converted into current source, so 4 ampere in parallel with the resistance. Now let's again convert this voltage source of 12 volts in series with resistance of 6 ohms to a current source. So I is equal to V by R. 12 by 6 will give you 2 amperes in parallel with again the resistance of 6 ohms. Now 6 ohms and 3 ohms, as you can see in figure B, are in parallel. So the resultant is 6 into 3 by 6 plus 3, that is 18 by 9, that is 2 ohms. So there will be 2 ohms and an 8 ohms in parallel, and the total current, the current is 4 amperes is in upward direction and 2 amperes is in downward direction. So the resultant of that will be 2 amperes in upward direction, because the highest value is of 4 amperes. So now if we can apply current division rule, current I is equal to total current 2 into opposite branch resistance 2 by total resistance 8 plus 2, that will give you 0.4 amperes. That is the value of current that is flowing through 8 ohms. Now what is the voltage across it? V is equal to I into R. What is I value? 0.4, R value is 8, so that will give you 3.2 volts. Now coming to the Kirchhoff laws, a voltage law and current law. The Kirchhoff is a German physicist, stated two basic laws in 1847 concerning the relation between currents and voltages in an electrical network. Kirchhoff's laws, along with Ohm's law, forms the basis of circuit theory. This Kirchhoff was born to a lawyer in Königsberg, East Prussia. Kirchhoff entered the University of Königsberg at the age of 18 and later became a lecturer in Berlin. He stated two laws. So the basic concepts that you have to know before getting to this Kirchhoff's voltage law and current law, you need to understand what are node, branch, closed path and a mesh. A node is something at which the terminals of more than two components are joined. A circuit branch is between any two nodes consisting of more components connected in series. That is, anything which connects any element that is present between two nodes is said to be a branch of that particular circuit. Now what is a closed path? Starting at a point in a circuit node, proceeding through the connected electrical devices back to the starting node, that is point, without crossing a node more than one time, forms a closed path. You can see voltage source and resistance in parallel. This is a closed path, and resistor and a capacitor, that is also a closed path. So these are nothing but closed paths, starting at a point and coming to the same point, tracing through the rest of the elements. Now what is a mesh? Mesh in a circuit is any closed path starting and ending with the same node, not passing any node or branch twice. That is nothing but a mesh. Now what is Kirchhoff's current law and Kirchhoff's voltage law? We'll see the statements of that. Kirchhoff's current law and Kirchhoff's voltage law are the fundamental laws of the circuit analysis. KCL is basis of nodal analysis, in which the unknowns are the voltages at each of the nodes, and KVL is the basis of mesh analysis, in which the unknowns are the currents flowing in each of the meshes of the circuit. Kirchhoff's voltage law. The algebraic sum of all the branch voltages around any closed path in a circuit is always zero at all the instances of the time. If you can see, there are three resistors connected in series, R1, R2, R3, and there is a supply voltage Vs, and because of this there is a current that is flowing I. As all the resistors are connected in series, the current through all of them will be same, and there will be a voltage drop of V1, V2, V3. And Kirchhoff's voltage law, according to this, algebraic sum of all the voltages is 0. That is, minus Vs plus V1 plus V2 plus V3 is equal to 0, or you can write Vs is equal to V1 plus V2 plus V3, which is nothing but the algebraic sum of all the voltages is equal to 0, or sum of voltage rise is equal to the sum of the voltage drop. So what is the voltage across resistor R1? I into R1, because the current is same, and voltage across R2, I into R2, and voltage across R3, I into R3. So current I is equal to Vs by R1 plus R2 plus R3. You can write by using voltage division rule, voltage across V1 is equal to total voltage into same branch resistance R1 by R1 plus R2 plus R3, total resistance. Similarly, you can write V2 and V3. Vs into R2 by R1 plus R2 plus R3 is V2, and Vs into R3 by R1 plus R2 plus R3 is V3. Now let's take an example. There are 5 resistors which are connected in series with an applied voltage of 15 volts. Determine the unknown voltage drop for the given circuit. That is, you are asked to find plus V. As you know, sum of the voltage rise is equal to sum of voltage drop, or algebraic sum of all the voltages is equal to 0. 15 must be equal to 2 plus 1 plus V plus 5 plus 3, or minus 15 plus 2 plus 1 plus V plus 3 plus 5 equal to 0. That gives you V is equal to 4 volt. Kirchhoff's current law. The sum of currents entering node is equal to sum of currents leaving node, or algebraic sum of all the currents at a node is equal to 0. The sum of all the currents entering a node is 0 if all the currents are assumed to be entering the node. Algebraic sum of all the currents is equal to 0 if the condition is if all the currents are assumed to be entering the node. If you can see, there are three resistors connected in parallel, and because they are connected in parallel, current will get distributed and voltage across each and every element will be same. Let's take a current is flowing because of voltage source. The total current IT will enter into these resistances as I1 plus I2 plus I3. That is, I1 is the current flowing in R1 resistor, I2 is the current in R2 resistors, I3 is the current in R3 resistors. And voltages V1, V2, V3 are nothing but the same voltage Vs. From the figure, all the algebraic sum of all the currents is equal to 0, or I total is equal to I1 plus I2 plus I3. Now let's take an example. There are three resistors connected in parallel with a source current. Determine all the currents in all the resistors for the given circuit. Applying Kirchhoff's current law, I is equal to I1 plus I2 plus I3. Now let's take voltage at node A is V. So I1 is equal to V by 2 and I2 is equal to V by 1. I3 is equal to V by 5. If the current is unknown and voltage is assumed to be V. Now I is equal to V by 2 plus V by 1 plus V by 5. That is, V is equal to 10 volts. Now I1 is equal to 10 by 2 5 amperes, I2 is equal to 10 by 1 10 amperes, I3 is equal to 10 by 5 2 amperes. What is the total current? 5 plus 10 plus 2. Now let's see whether you have understood the concept of source transformation and KVL and KCL better. For this I'm gonna give you a quiz. Let's start the questions in quiz. The source transformation is a, what is it? It's a reproductive technique or simulation technique or production technique or a reduction technique. Now, using source transformation technique, a complicated network can be converted into a canonical form, simple form, sample form, coexist. Using the source transformation, the calculation of the complicated network can be made easier, complicated, costlier, none of this. Now, basically, the two types of sources in the source transformation are either it's a voltage source or a current source, or both voltage and current source, or all the. From the figure, what is the open circuit voltage? There is a figure, Is current source and parallel with the resistance. What is the value of voltage? You can use Ohm's law. From the figure, what is the short circuit current? What is the current that is flowing? If you short circuit A and B terminals, what is that current? So determine the equivalent current source for the voltage source shown in figure. Voltage value is 50 volts, resistance is 50 ohms. You need to determine current source value. Now check your answers with these. If you have solved all the questions, and check all the answers from 24 to 30 and see whether you have done everything correct. If there is something that's wrong that you have done, just go through the video once again so that the concepts of source transformation and Kirchhoff's laws are clear. Kirchhoff's laws are very basic fundamental laws, and which are very much useful for the electronic subjects that you come across in the next semesters, which will be very much helpful for you if you clearly understand these concepts. And also we have solved some quiz on source transformation. Let's also see on Kirchhoff's laws. The fundamental laws of circuit analysis are, as you can see, you know better, and the Ohm's law is applicable too. And a 12 ohm resistor is connected across 12 volts battery. A resistor is connected across a battery. How much current flows through the resistor? Simple Ohm's law. Kirchhoff's current law is used in, is it used in mesh or super mesh or super node or node? Now apply KCL to this given circuit to the right, and which one is correct, identify and write the answer. Now the mesh analysis is applicable for planar networks or non-planar or both or none. Check your answers with them after you have done the quiz, whether they are correct or not. And if you have any problem, just go through the video once again and the concepts. If they are clear, then you'll be able to easily solve this quiz, which are very fundamental questions. And this is the end of the lecture 4. Thank you.